Hello everybody, my name is Javier Perez and this is my final project presentation. So the app that I decided to do is a mineral identification app. So the purpose of this app is to help individuals identify minerals based on a specific criteria. It can be used by both novices and intermediates alike. And once you click on an app, it'll show you, once you click on a mineral, it'll show you specific details on that mineral. This is the UI of my app. So basically you start off with the table view on the top left side, and it's got all the minerals listed there. And from there you can click on a mineral and it'll take you to the description table view, which is this one right here. And then here it shows you basic information about the mineral, shows you a larger picture of the mineral, and it shows you the location of the mineral itself. And if you click on the segmented controllers, it'll direct you to one of the other view controllers. So if you click the empirical one, it'll take you to the empirical view controller, this one right here. And it'll show you its composition, it'll show you its empirical formula. And then if you click on this section, it'll take you to another segmented controller, which you can select whether you want to see the mineral in cross-polarized or plane polarized. And these are just minerals under a microscope with different light sources shine through them. And then if you click on the crystal system, it'll take you to the crystal system view controller, which shows you an image of its crystal system. So this one is monoclinic, so this is typically what the structure of a monoclinic mineral is. And then it gives you basic information on the mineral. And then if you click on the more info bar button on the top right, it'll take you to a UI web controller, a web view controller, which is right here, and it'll pretty much redirect you to a website that has more information on the mineral. And if you go back to the mineral identification table view, right here, it'll pretty much show you a search bar. And you can click on it, and it'll redirect you to 4 UI picker views. And from there you can select like the primary color, secondary color, streak color, and hardness. And when the user is done selecting those and clicks finish, it'll redirect them back to the view controller, but with the table reloaded with that specific criteria. So if the user only knew that the color, his primary color was red, it'll filter back all the minerals that have a red color to them, either in the primary as a primary color or as a secondary color. So this is my UML class. So basically everything is pretty much done in the view controller. I tried creating a separate class for handling Firebase, but because I have to keep reloading the table view when the user queries, it wasn't working properly and the table view wouldn't reload. So I had to incorporate the Firebase and its initialization, retrieving all the data, and storing it all in the view controller. It's not ideal, but yeah, I couldn't get it to work any other way. So the view controller pretty much has this function called fetch minerals, which basically what it does is it gets all the data from Firebase, and I stored it in a dictionary, which I then stored into an array of type model, so a model class right here. So in my Firebase database I have all these variables and components with their specific value in them. So I have a name, I have a color 1, color 2, composition. So pretty much everything that's on Firebase gets stored into that array. And from there, it'll pretty much use the table view and it'll populate the table. And let's see. And there's a lot of also for the querying part, I just created a separate view and just made it invisible, and then once the user clicks the search bar, it'll become visible again. so I didn't use a separate class for that. And from there, as you saw before, it had the four picker views where they can select the color, texture, the color, hardness, and streak color. And all of the operations of querying is handled in the query mineral function right here, which it takes 4 strings, which is pretty much the values that the user selected in the table in the UI picker view. And then it pretty much reloads the table by calling a Firebase method called query by child. So I set the primary key to be color 1, and then from there it's if and where clauses based on the other 3 picker view items that the user selected. And then after that, it'll pretty much go back to the table view and it'll show you a populated table with that specific criteria. And it also, all these variables are there, like I mentioned, there's a lot of them because of the Firebase. And because I use segues to pretty much redirect all that information to the other view controllers. And you might notice that there's duplicates on the other controllers, and that is because for some reason when you click on, like I tried using an unwind segue, but if you click on the segmented controller multiple times to get redirected to different view controllers, it'll crash sometimes. So by doing it this way, it's redundant, but it makes it so that the view controller, so it makes it so that it won't crash. And as I mentioned earlier, each individual view controller has its own components. So empirical view pretty much has 2 UI text fields with the information that gets passed on from the view controller and the other controllers depending on which segmented controller gets pressed on. The more info controller pretty much has a UI web view in there, and the operation, I pretty much can use the string concatenation on the first part of the HTTP, and then I add the name of the mineral to it, and then I finish it off with the rest of it. So then whenever the user selects, let's just say they select barite, then the name barite will get stored into that, it will get stored into the URL, and then get concatenated together, and then I do the web view load request on that link, on that URL, and I pretty much just load that specific web page with that specific mineral's content. In terms of data sources, so the picker view have picker views and table views, and those are all in the view controller because, like I mentioned earlier, almost everything is handled in the view controller. And yeah, this is my MVC architecture. There's a little bit of errors there, like some of these say core data, but it's actually Firebase or DB, so ignore those. But basically, the controller fetches a mineral from Firebase, retrieves all the data, handles saving the data, retrieves the location of the mineral, retrieves the images, the links, and it pretty much communicates with the view based on user actions. So pretty much if the user taps on the search button and decides to filter by color, then it'll notify it via the data sources that, hey, the user picked this, so the table view is going to reload. And in the, like I mentioned, each controller has its own unique components. So they display the minerals, it displays the images, description, location, microscopic view, chemical formula, crystal structure, and more information in the app on the web view. The model, pretty much like I mentioned earlier, the model is pretty much variables that are identical to the ones on Firebase. So the model and the view controller work together to store all those variables and store them into that array of models, which then communicates with the table view. And there are no updates required. User updates, it only updates when the user queries, and notification is done when the user selects. Notifying between controller and views when the user selects the table view cell, and then it'll redirect them to different, like the mineral, depending on the mineral, it's going to have a different location associated to it. Limitations, well, with large amounts of data, Firebase actually has some loading time issues. So loading all that data into the database took a few seconds, which probably would be faster than core data, but not as well. It does not allow for adding a mineral, so you can't add new minerals to the database. You can change the images, and because certain minerals have different varieties of the same kind, so there might be minerals with different texture, different color, and the user might still not find the mineral because they might have one that isn't specific to the criteria that I have set when you're querying. And with data currently stored in the online database, the user currently needs to have internet connection at all times to get all that information, because without it, it'll just be a blank table view. Takeaways. So I learned how to use Firebase, and starting sooner would have been better, because learning Firebase, its methods, and creating my own query was a little bit difficult, and that took a lot of time to learn. So starting sooner would have been a lot better. In terms of storage, Firebase works a lot better than core data, because if you have like 2,000 minerals and you store them all into core data, then that would be a lot of information and it would take up a lot of storage. But by having everything in Firebase, everything just gets retrieved from that online database. I learned how to make tasks asynchronous to the loading time. So at first, the table took about 20 seconds to load originally, and then after making certain things, like loading the table, for example, I made it separate and I made it asynchronous. So it actually loaded the table in like 6 to 7 seconds, which was a big improvement. And I learned how to apply many of the concepts learned in class. So I applied Firebase, I applied images, UI web views, picker views, table views, data manipulation, MVC architecture. Also improvements. So I'm going to work on this out after the semester ends, and I'm going to try to load it onto the App Store. But these are some of the things that I think I should probably implement at some point. So basically, allowing users to add their own minerals. So currently, you cannot add your own minerals. So allowing the user to add their own minerals would probably benefit, because I might not have all the minerals in the database. I might not get all of them. Allowing users to change current images of the minerals would also be beneficial, because they might have a sample that isn't remotely close to what I have on the main image or the table image. So by allowing the user to change those, they can kind of recognize what the mineral is based on the sample that they have. Also making the content broader. So currently all the information is very like, there's some chemistry in there, there's some just very basic description, location, but mostly it's like information related to geology, and it'll be beneficial to mostly geology students. So probably having information that hits a broader audience would benefit. I also thought about integrating machine learning. So if the user takes a picture of the mineral, they find a mineral and they take a picture of it. So by using machine learning, like it should be able to like recognize certain features of that mineral, like the color, and the texture and all that stuff, and it should be able to do like a self query on the database and just bring up what that mineral could possibly be. And that'd be something really cool that I'm gonna look into after the semester ends. Uh, I was thinking about including rocks as well, because minerals are mostly found there. While they're found isolated just by themselves, they're also include like there's inclusions in rocks where these minerals are found. So having rocks and minerals would probably be beneficial because certain minerals are in rocks. And also adding Firebase offline capabilities for data persistency. So I didn't use the Firebase offline capabilities because I didn't know about them. But basically, Firebase has some capabilities where you can have persistent data. So if the user loses internet connection, the user would still be able to access the minerals without having the table view just go blank. So probably adding data persistency for offline would probably be beneficial. And that is my presentation. Thank you very much.